Hello friends, welcome again. Today we will be solving a problem related to DC series motor, and the problem is a DC series motor drives a load where the torque is proportional to the square of speed and the resistance of the motor can be neglected. So what should be the percentage reduction in the terminal voltage such that the speed becomes half of the speed at full voltage? Okay, so this is what is the question, and we can remember some of the relations which we can use here. Okay, so the first relation will be tau is proportional to phi into Ia, where tau is the torque and it is proportional to the field flux. This is field flux. Okay, and this is our current, which is armature current. Okay, armature current. Okay, so this is tau is proportional to phi Ia. This is first relation, and the back EMF E is proportional to phi into N, that is the flux, field flux, and speed of the motor. Okay, now for DC series motor, okay, this relation can be applied as, because see here Ra, okay, Ra is 0. Okay, so you can say that V is equal to E. Okay, that is the first thing that we notice. Okay, the applied voltage is same as the back EMF. Also you can notice one more thing, that the same current flows through the field winding which flows through the armature. Okay, so hence flux will be proportional to Ia, the field flux, if the armature reaction is neglected. Okay, hence tau is proportional to Ia squared. Okay, also E is now proportional to Ia into N. Okay, which was earlier proportional to phi A into N. Okay, which was earlier proportional to phi A into N is now proportional to Ia into N. So these are the relation we should keep in our mind before proceeding. Okay, now you can see here that let's say the voltage, full voltage was V1, and let's say the reduced voltage is V2. Okay, and the reduced voltage is V2, and at the same time for that scenario, let's say Ia1 was the full current, that is the current which was flowing when full voltage was applied, and Ia2 was the current which was flowing when the speed was reduced. Okay, or when V2 was applied. Similarly, at that time, say tau 1 was the torque when the voltage was full, and tau 2 was the torque at the reduced voltage. Okay, and the speed N1 is the speed at full voltage, and N2 is the speed at the reduced voltage, and E1 is the back EMF at full voltage, and E2 is the back EMF at the reduced voltage. Now we know one relation, that N2 has to be half of N1. That's what is written here. Okay, speed has to be half of the value at full voltage. Okay, now what we can see is we can use a simple relation here, that he is asking, he's telling us that torque is proportional to the square of speed. So let us write it. So tau is proportional to n1 squared, and tau 2 is proportional to n2 squared. Okay, again we know that tau 1 will be proportional to the current which is flowing at that time, squared of that. Okay, so this is the armature current at that instance, so it should be proportional to Ia1 squared. Okay, and also this is from the motor property, so tau 2 is proportional to Ia2 square. Now if you do this relation and write it in one line, so it is like tau 1 over tau 2 is equal to n1 squared over n2 squared, and which is equal to Ia1 squared over Ia2 squared. So this relation we can write. Okay, okay, now this is a very important relation for this question. Now you can also write n1 over n2 whole squared will be equal to Ia1 over Ia2 whole squared. Okay, you can write this now, Ia2 whole squared. Now what you can do here, you can drop the powers, and you can get n1 over n2 is equal to Ia1 over Ia2. Okay, you can write it right there. Now you can see here that n1 and n2 again has a relation, we can use that relation. So n1 over n2, if you do that, it is 2 from here, so you can substitute it here, so it will be twice equals to Ia1 over Ia2. Okay, so this is what we get. Okay, let me write it again. We get 2 is equal to Ia1 over Ia2. Okay, or Ia2 will be half IA1. Okay, and the other relation now that we can use is E is proportional to E1 is proportional to phi 1. Okay, now instead of phi 1 I can write directly I1. Okay, IA1 into N1. Okay, similarly E2 is proportional to IA2 into N2. So now E1 over E2 can be written as IA1 N1 over IA2 N2. Okay, now we know both the relations. This is the relation of IA2 with IA1, and N2 is also half of an N1. This relation already we know because it's given in the question. Okay, so we can substitute both the relation in this equation. Let's say this equation is 2. So E1 over E2 will be IA1 over IA1 into N1 over IA2. IA2 is half of IA1. Similarly, N2 is half of N1. Okay, so we can cancel all these. Okay, so what we get, E1 over E2 is equal to, these two halves will give me 1 by 4, and this will go up, so it will be E4. So E1 is equal to 4 times E2. Okay, but E is same as V, as we discussed earlier, because the armature distance is neglected. So V1 is 4 times V2, or V2 becomes 1/4 of V1. Okay, so now what is the change in the voltage? Change in voltage is V1 minus 1 by 4 V1. Okay, over V1 into 100. So if you solve this, this comes out to be 3/4 into 100, which is 75%. Okay, this is the percentage change. Okay, so what is the answer? B is the correct answer for this question. Okay, so this is how we need to solve for the questions related to the relations between the load torque and the load. Okay, so thanks for watching.